Hi students, this is Karthik Trivedi and you are watching a lecture series of engineering graphics and design with me. So in last lecture we have seen what is scale, what are the different types of scale. In this video we gonna see the example of plane scale. But before we start example of plane scale, let's see what is exactly the plane scale is. So a plane scale consists of line divided into suitable number of equal units, or you can say suitable number of equal parts. The first unit is divided into the smaller part, subdivided into smaller part. Now let me tell you something. The plane scale is used when you have to measure a one main unit and other subunit. Now what is first, you have to understand what is main unit and what is subunit. So in last video I have told you to mug up all the unit conversion formula, like 1 centimeter equal to 10 mm, like 1 meter equal to 10 decimeter, like 1 kilometer like 10 hectometer. So these all are the formulas which I have already told you to mug up. So here the 1 centimeter is equal to 10 mm. That means a centimeter is a main unit and mm, which is the 10th part of centimeter, is subunit. Same way for 1 meter equal to 10 decimeter. That means meter is a main unit, whereas decimeter is a 10th part of meter. So decimeter is known as subunit. So now you will get to know that what is main unit and what is subunit. So main unit and subunit is 10th part of main unit. So like 4 centimeter 3 mm. Like say in example he will ask you to construct a plane scale to show a 4 centimeter and 3 mm, or you can say 4.3 centimeter. It is nothing but 4 centimeter and 3 mm. So here a centimeter is main unit and mm is a subunit. Why? Because we know that 1 centimeter is equal to 10 mm, whereas mm is the 10th part of centimeter. So here centimeter is main unit and mm is a subunit. Same way for 1 meter equal to 10 decimeter. So here a meter is a main unit and decimeter, which is a 10th part of meter, is a subunit. So now you will get to know that the plane scale is used to show a main unit and a subunit. Now there are so many things which is over here, but I am not going to going through this because it is very cumbersome and it is very theoretical. What I am going to told you, or what I am going to show you, is that first we will solve one example of plane scale, and through that example we are going to clear our concept of plane scale, and then I am going to come here over this current slide. So let's directly jump on to the example of plane scale. So now we are going to solve the example of plane scale, and through this example we are going to clear our concept of plane scale. Okay, so here the example is given. Draw a scale 1 centimeter is equal to 1 meter to read decimeters to measure a maximum distance of 6 meter. So it a distance of 4 meter and 6 decimeter. So here the example is given. So in any example of plane scale, first thing you have to find is called representative fraction. So we know that representative fraction is nothing but equal to the drawing dimension upon actual dimension. So here in example, in the first line he says draw a scale 1 centimeter is equal to 1 meter. That means there is a one line of 1 meter and you have to represent that 1 meter line by a 1 centimeter line. So here a drawing dimension is 1 centimeter, whereas actual dimension is 1 meter. So I will write RF is equal to drawing dimension, which is 1 centimeter, upon actual dimension, which is 1 meter. Now in this example, in numerator drawing dimension is in centimeter, whereas in denominator actual dimension is in meter. So I already told you the representative fraction is a unitless quantity. So if numerator and denominators units are different, then you have to make it same. So here in numerator we are having a 1 centimeter and denominator we are having a 1 meter. So I am going to convert 1 meter into centimeter. So you know that 1 meter is equal to 100 centimeter. So RF is equal to 1 centimeter upon 1 meter, which is equal to 100 centimeter. So 1 centimeter upon 100 centimeter. So your representative fraction is going to become centimeter going to become, and a value of RF will be 1 upon 100. So that's how you can find the value of RF. Second thing that you have to find is length of scale. So now you know this equation, length of scale is equal to representative fraction multiplied by maximum distance. Now the RF that we have already defined, which is 1 upon 100, but what is maximum distance? So maximum distance is always given in the example. So here in the first line of example, draw a scale 1 centimeter equal to 1 meter to read decimeter to measure a maximum distance of 6 meters. So here the maximum distance is given, which is a 6 meters. So we are having a maximum distance is equal to 6 meters. So 1 upon 100. So you know that length of scale is equal to RF multiplied by maximum distance. So 1 upon 100 multiply by maximum distance, which is 6 meter over here. But always remember, your value of length of scale must be in centimeter. So here a maximum distance is in 6 meters, so I am going to convert it into the centimeter. So you know that 1 meter is equal to 100 centimeter. So length of scale is equal to RF, which is 1 upon 100 multiply by maximum distance, which is 6 meter over here. So 6 multiply by 100, so it will be 600 centimeter. So is equal to RF 1 upon 100 multiply by maximum distance 600 centimeter. So is equal to 6 centimeter. So we have find length of scale is equal to 6 centimeter. So for any kind of plane scale example, this two step is fixed. First you have to find RF, and second you have to find length of scale. Now what he has said right now, that you have to show a distance of 4 meter and 6 decimeter. So now we are going to sketch a plane scale in a drawing book. Now what you have to do, you have to just pause this video, and whatever I am showing you over here, you have to repeat the same in your drawing book, and you will definitely solve this example. So here first we have a length of scale is equal to 6 centimeter. So first step, draw a 6 centimeter horizontal line. So now see it on your screen. First I am going to draw a 6 centimeter horizontal line. Now we have to divide this 6 centimeter horizontal line into some suitable number of equal parts. But now the question comes in your mind, sir, what are the suitable numbers of equal parts? So that depends on the maximum measurement that is given in the example. So here the maximum distance is given, which is 6 meter. So that's why we have to divide this line into 6 parts, such that each part will show 1 meter. So total 6 part means it will be equal to 6 meter. Let's say instead of maximum distance 6 meter, let's say in the example, if he has given a maximum distance of 4 meter, then I am going to divide this line into 4 equal parts, such that one part will represent 1 meter. But here in this example, a maximum distance of 6 meter is given. So that's why I am going to divide this line into 6 equal parts, such that one part will represent 1 meter. So let us divide this line into 6 equal part. After dividing this line into 6 equal part, you have to draw a 10 mm vertically up line at each part. So you can see that at each part I am going to draw a 10 mm vertically up line. Why I am going to draw this 10 mm vertically up line? Because it will be look like a scale. So there is no fixed rule that you have to draw only 10 mm vertically up line. You can draw a 20 mm vertically up line as well. Okay. So what I have done over here, again I am going to repeat this thing over here. So first you have drawn a 6 centimeter line. So first you have drawn 6 centimeter line. Now you have divided this into 6 parts. How you have decided? You have decided as per the maximum distance given. So maximum distance is 6 meters. So that's why you have divided this line into the 6 part. After dividing this line into 6 equal parts, at each part you have drawn a 10 mm vertically up line. So now you can see that at each part we have drawn a 10 mm vertically up line. Now you can calculate from the left 1, 2, 3, 4, 5 and 6. So there are total 6 parts over here. Now what we gonna do? We have to give numbering. So to give numbering, what you have to do? From the left, from the extreme left, you have to avoid the first unit, or you have to avoid the first part. So from left portion I am going to avoid the first part, and after avoiding first part I will start giving numbering. So you can see that I am going to avoid the extreme left portion, and after that I am going to start giving numbering. So you can see the 0 already written over there. Then 1, 2, 3, 4 and 5. Okay, so what I have done, you have to remove. Always you have to avoid the extreme left portions, and after that avoiding the extreme left portion you have to give numbering 0, 1, 2, 3, 4, 5. Why you have to avoid extreme left portion? Because extreme left portion is used for the subunit. So here in this example, a main unit, because we have to measure a 4 meter and 6 decimeter. So here main unit is meter and subunit is decimeter. So extreme left portion is for subunit, which is decimeter. So now from the right side of the 0 will show the meter. So 0, 1, 2, 3, 4, 5 will show meter, and to the left side of 0 will show a subunit, which is decimeter. So now we have to divide the extreme left portion, which is showing the subunit. So now we have to divide the extreme left portion that we have avoided. So we have to divide it into some suitable number of equal parts. But how many parts? So that for that you have to remember the conversion. So here a main unit is meter and subunit is decimeter. So you know that 1 meter is equal to 10 decimeter, and the extreme left part will show a subunit. So that's why we know that 1 meter equal to 10 decimeter. That's why I am going to divide the extreme left portion into 10 equal parts. So as you can see that now I am going to divide this into extreme left portion into 10 equal parts. So you can see from the left side of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So left side of 0 will show decimeter, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And right side of 0 will show meter, 0, 1, 2, 3, 4, 5 meter. So 0 to 5 meter, and left side of 0, 0, 1, 2, 3, 6, 5, 7, 8, 9, 10 will show decimeter. Okay, now what we gonna do? Now we are going to cover this scale by some rectangle. So let us see over here how we gonna show. So this much is already done. So now I'm going to cover it by one rectangle. So see the figure very carefully. Yes, like that. Again I'm going to repeat. Yes, like this. So it will look like a scale. That's why I'm doing this. Okay. Now on the extreme right side of this figure we will write main unit. So we know the main unit is meter, and on the extreme left portion we will write subunit. So it will be a decimeter. So on the right side we will write meter. So see on the screen, on extreme right side we will write meter, and on the extreme left side we will write decimeter. See on the screen. Now we have to measure 4 meter and 6 decimeter. So now you know that on the right side of the 0, but before I am going to do this, we have to write the value of RF in just below the plane scale. So we will write the value of RF, which is 1 upon 100. So you have to write main unit, subunit and RF in one single line. Okay, like this. Now we have to show a 4 meter and 6 decimeter. So you know that from right side of 0 it will show meter, 0, 1, 2, 3, 4, 5 meter, and the left side will 0, left side of 0 will show decimeter. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimeter. So now first I will find 6 decimeter. So I have to go to left side of 0. So I have to find 0, 1, 2, 3, 4, 5, 6, and I have to mark 6 decimeter, and from there I have to draw extension line. So you can say that I will draw on the extension line on the 6 decimeter. Again I am going to repeat. First I will find first I will go to the left side of 0 and I will find 6 units. So 0, 1, 2, 3, 4, 5, 6, and then shows the 6 decimeter, and from there I am going to draw extension line. So now you can see that I am going to draw extension line on the 6 part. Yes, like this. Again I am going to repeat. See the left side of 0, 6 part. Yes, like this. This will be a 6 decimeter, and now I have to show 4 meter. So I have to go to the right side of 0. So 0, 1, 2, 3, 4, and from 4 I will draw a 1 extension line. Yes, like this. Again I am going to repeat. See the right side of 0 from point 4. Yes, like this. So it will show 4 meter. So 0 to 4, right side of 0, 0 to 4, 4 meter, and left side of 0 to 6, it will show 6 decimeter. So now left side of 0 we will having 6 decimeter, and at that position we have extension line, and right side of 0 we will having a 4 meter, and from there we have extension line. Now connect it with arrowhead and we will have 4 meter and 6 decimeter. So this is how you're gonna solve this example. Let us say instead of 4 meter and 6 decimeter, if you would ask to find 2 meter and 5 decimeter, then what you will do? To find 2 meter and 5 decimeter, what we will do? Yes, you are right. You will move right side of the 0. So you will move 0 to 2. So it will be a 2 meter, and to 5 decimeter, what you will do? You will go to the left side of 0 and you will go to the fifth point. So you will go to the fifth point, which is left side of 0, which will be 5 decimeter. So here right side 0 to 2, 2 meter, and left side of 0 to 5, which is 5 decimeter. So that's how you can find 2 meter and 5 decimeter. So this is how you can solve any example. So this is the master example. Repeat this video again and again, and you will master the plane scale example. Now let us come on to the main thing that I already told you, that before I am going to solve, first I am going to solve your concept through this example, and then I am going to come with the plane scale definition. So now you can understand a plane scale consists of a line divided into suitable number of equal unit, and the first unit is divided into the smaller parts. So that we have already done. First we have divided the line into some suitable number of equal parts, and that depends on the maximum distance. Then extreme left portion we have avoided because that is used for subunit. Now 0 should be placed at the end of first imaged unit. So what we have done, we have avoided the extreme left portion, and after that we have started giving numbering from from 0, 1, 2, 3, 4, 5. Now what he says in the third point, from 0 mark the unit should be numbered to the right and subdivision to the left. So we already know from right side of 0 will show the meter and left side of the 0 will show decimeter. So right side of 0 will show man unit and left side of 0 will show sub unit. The fourth point, the units and subdivisions should be labeled clearly. So on the extreme right side we have written meter as a man unit, on the extreme left portion we will write decimeter as a sub unit. The RF should be mentioned below the scale, so that we have already done it in an example. So this is how through this example you have understand the plan scale is used for measuring a man unit and sub unit. I hope you will like this video. Have a nice day. Bye bye.